Hello everyone, welcome to Taylor's Classical Mechanics. This is going to be problem 4.6 from the book. So let's go ahead and read the problem description. It says, for a system of n particles subject to a uniform gravitational field G, acting vertically down, prove that the total gravitational potential energy is the same as if all the masses were concentrated at the center of mass of the system. That is that the potential energy, the total potential energy, is just a sum over alpha of each individual potential energy use of alpha for each particle, which is just then equal to capital M times G times capital Y, where capital M is the total mass of the system of particles, and capital Y is the Y coordinate of the center of mass of all the particles. So essentially it gives us a hint from problem 4.5, and it's a pretty straightforward problem, but you kind of need to reference something from earlier in the book, in the textbook, from chapter 3, I believe, where it talked about the center of mass. So real quick, I write down that the total potential energies is the sum of the individual potential energies over alpha. So we have the summation over alpha times little m sub alpha, which is just the mass of each particle, times G, times y sub alpha, which is just the y coordinate of each individual particle, because every particle could have a different y value, right? We're just talking about the gravitational potential energy here, so that's the potential energy for gravity. So the total potential energy is a sum of the individual potential energies due to gravity, right? That's all this expression is saying. Now, if you look at chapter 3 and look at the definition for, the things like the center of mass, well, the y coordinate of the center of mass of a system of particles can be written as 1 over the total mass, m, times the summation over alpha of m sub alpha, y sub alpha, which is just like a weighted version of the position. So we're weighting each y by the mass of each particle, weighting each position here by the mass of each particle. And that gives you the y coordinate of the center of mass of a system of particles. Well, then we can just rewrite this as that the summation over alpha of m sub alpha, y sub alpha, which is what we have here, is equal to capital M times capital Y. Therefore, we can just take this expression and plug it into here and just show that the total potential energy of the system of particles is just equal to, if we replace the sum m sub alpha, y sub alpha with this, then we just get G capital M capital Y, where M is the total mass of all alpha particles, and capital Y is the y coordinate of the center of mass of all the particles. And really that's all there is to it, right? Like, just using the definition of the center of mass, you can rework this potential expression to show that the total potential is just related to the center of mass of the system of particles. All right. Well, that sums it up for problem 4.6. If you guys have any questions, comments, concerns, feel free to let me know in the comments below. If you guys want to support my channel, you can do so by, of course, subscribing to the channel, leaving a like on the video. You can, use a donation link to donate to my YouTube channel via the Buy Me a Coffee link, as well as Patreon. You can do that as well to get access to the written versions of these solutions if you prefer that as well. So thank you guys for watching, and I'll see you guys on the next video.